plot a kidnapping or an assassination. You want to plot out the movements to know what to do, or get in to plant a listening device,
Yep.
or so there's a whole variety of motives behind it.
Oh,
That I think are worth bringing out.
oh yeah, exactly. And this is pretty much everything we're talking about here can be used for both a positive and a negative. Hopefully, for the most part, we're going to assume that, you know, with most of this stuff, we're going to be looking at it from an investigative with the privacy controls in place. But you're so right. One of the biggest things they warn when you're looking at, you know, hardening the target as far as executives who are traveling in foreign countries or a possible kidnap is you change your pattern. You don't do the same route. You become very aware. But the same information on the flip is a positive when you're looking at Spaff couldn't even done it. He wasn't even home. He was having coffee. Or flying to pull, or he got lost. He's out driving in his car. Connecting the dots becomes, it's easy to say, oh yes, we can take all this great stuff and we can wrap all this magical context and content on it and look at what it means and figure it out. But how do we do that? How do we do that when you've got 5 terabytes of information to look at? And, oh, by the way, you've got tools that were designed to connect the dots when a 10 meg hard drive meant you were a super user. Guys, these are not easy questions. This falls into the realm of, you know, the sciences of information retrieval, database. All these need to come together to try and make this information mean something. One of the ways that you need to connect the dots, or one way to connect the dots, is something called pattern analysis. What patterns appear when you look at this? Chronologies, timelines are another kind of a fundamental. How do we know what occurred when? Timelines, cause-effect relationships. We look at A happened, then B happened, then C happened. And timelines are something that I think we've struggled with in computer security in general. How do we understand the how do we trust the timelines? What do these timelines mean? Frequency analysis, that's another potential area for looking at this. How often did this occur, did X occur versus Y? And what does that mean? How often did they send email to this particular subset of IP addresses? Gee, could that mean something? Again, it depends. It depends upon the context and depends upon the meaning of everything else around it. Hierarchical connections or nodes. This is really an interesting way. Everybody hear of the 7 degrees of separation from Kevin Bacon? Okay, basically, you try to figure out, okay, you got Kevin Bacon, and you take any actor or actress in Hollywood, and the game is how quickly can you take it back to them somehow being associated with Kevin Bacon? Through the movie he was in, through somebody he's dated, or through something else. And it's really interesting kind of a party game. Well, that goes back to what's called small world networks. Yep.
I'm 3 separated.
You're 3 separated. Yeah, it's really interesting. And there's been a lot of research done on these small world networks looking at degrees of separation in social networking, densely connected nodes. So not only can we look at what's on that system, we can go out now and look at your social network. We can look at who is connected, who are you connected with, and if we can find that virtual Kevin Bacon that everybody's connected with, wouldn't that be, from an intelligence perspective, wouldn't that be a brilliant place to go plant all our listening devices? To go look at. From a privacy perspective, that'd be something we want to protect. If that's a super connected node, we want to make sure that there's some controls around that, so you just couldn't drop in there and now have information and have knowledge about a whole bunch of other seemingly unconnected. And this is something that is kind of the holy grail right now of what they're looking at out there in the intelligence and surveillance world related to this. But it means something. We can find those super connected nodes, we can find those Kevin Bacons, we can get an idea of what everybody else is doing without having to look at Spaffs separately, and that person's, and that person's, and that person's. And the structure of social networks falls right into that. You have very connected people who are friends with a million other people, right? So maybe if I want to find out what 50 people are doing, if I can find the one person that all 50 people are friends with, what can I do? I can go to that one Facebook page and I can look for what updates people or what people are doing. So if we find these hyper-connected or super-connected, densely connected nodes, that gives us information related to the social networks and the groups and what everybody else is doing. This guy's going, oh, this privacy, this isn't looking good.
So just to wander off a little bit, there are a whole lot of issues that the superconnected nodes are actually the ones that you may want to avoid, because they would be in a position to notice anomalous behavior of other elements in the network.
Yep.
And so knowing who they are helps you target nodes without the information rippling to the rest of the network.
Yes, and that, yeah. So basically, yeah, that's the flip side of that. A lot of stuff in the whole P2P, the whole idea of these peer-to-peer networking. A lot of that has to do with a lot of the surveillance is being done on a lot of these very connected nodes within the P2P. So either avoid them, or that's where you want to look at for people coming in off.
So an example that I've seen recently, although I haven't seen a write-up of it, and some of you may run into this, is on Facebook. A common tactic there is if someone's account is compromised, one of the frauds is to send email to everybody who's a friend saying, I'm in London, I've been robbed, I don't have my passport or any money, I'm in desperate straits, can you wire some money to me? And a few people fall for that. But it turns out that the hyper-connected individuals are those who are immediately able to say, oh no, I know where Roger is.
That's right.
And he's not in London, don't fall for that. And so in those cases it's a protective mechanism.
Yep, kind of a gatekeeper to that. Yeah, exactly. So that's why it's important to know who these are, to either avoid them or to be able to subvert them in a way to collect the information. Visualization is another way. We're visual beings. We look at things like graphical representation, heat maps, which things are red, which things are green. There's some really cool software out there that looks at, you have all this data from a computer system or from all these different drives or from a database. Based on the colors in there, they can represent something that may be of interest to you. So rather than just seeing a file structure with directories, they'll give you, if the size of the file is in excess of X, it will show up as this color. So, or it's between this range. You're involved in a case, and let's say we're looking for somebody producing child pornography movies, and we know the movies are within this range on average of sizes. You could actually use this, then I'll show me all the files then on this computer in red that would be within this range. Boom, comes up. It's much easier for us to look at from a heat map type of a structure than it is to start looking through by hand to figure out how big these files are. Dashboards are console UIs, user interfaces. These things come up and show us from in a restricted view, so we're not being overwhelmed with information, patterns and queries that we've asked for and that we've looked at. Timelines is kind of the more basic way. This is kind of how we started doing this. And timelines are great if we assume we can trust the timestamps on any of these things. And without getting into a lot of detail, that's a big question mark. Because timestamps, it's a user-controlled activity. You can change it. You can change clocks. You can have system failures. You've got the concept of clock skewing and drifting, where even if the clock is set accurately to the network time protocol server, after about an hour, depending upon how, you know, the system itself, 5 minutes could be off, half hour could be off. By the end of the day, they could be out by 2 hours. There's been some interesting research done in Australia that shows you, just from systems left alone on their own with no manipulation by anybody, how much the clocks have drifted and skewed from one day, 1 week to the next. So it makes timelines, that's the most basic way of doing it, but at least it's a start. Something that's coming up a little bit more recently, especially in the intelligence world, is this concept of mind maps. How can you drill down? How can you look at these dependencies, these interactions, in a way that, okay, I want to look at this. You click on that, and it shows you the connections. It shows you where which things are connected, and not just which things are connected, how connected they are. And you can drill down, you can do fly-throughs, you can stand the data on its head and look at it from different perspectives, and potentially get a micro view, back it off, and get a macro view. And sometimes, you know, the old saying, you can't see the forest for the trees. You're looking at the stuff at such a lower level that when you back it back out and look at it, go, wait a minute, this stuff is actually connected on a much higher level that you don't see if you're just looking at individual files within a directory structure.
And they're binary trees.
Yep, binary trees. Yeah, lot more ways of doing it. Okay.
Forest of the binary.
Voice of the binary trees.